What if we could take an incredible journey deep inside our own planet? Well, today, that's exactly what we're going to do. We're going to peel back the surface and explore the four massive layers that make up the Earth. Seriously, have you ever just stopped to think about what's really down there? Miles and miles and miles below where you're standing right now. We see the surface every day, of course, but what hidden worlds are churning away underneath? That's the big question we're diving into. Okay, so our journey to the center begins. But first, a really important question. How do we even know what's down there? It's not like we can just, dig a hole all the way through. Yeah, the deepest hole humans have ever drilled is barely a scratch on the surface. So how in the world do we know what's underneath? Well, it's pretty clever. Scientists basically give the Earth an ultrasound. When an earthquake happens, it sends out these powerful seismic waves. And by studying how those waves travel, how they speed up, slow down, or even bend as they pass through different stuff, they can create a map of the inside of our planet. And what those studies showed us is kind of mind-blowing. Earth isn't just one big solid rock. Nope, it's made of these really distinct layers. This all happened billions of years ago when the planet was just a big, hot, molten mess. The heavier stuff sank right to the middle, and the lighter stuff floated to the top. And that's how we got these layers, each separated by what it's made of, how hot it is, and how dense it is. All right, let's start our descent. We're beginning with the part of Earth we're most familiar with, the two outermost layers. First up is the crust we live on, and then we'll dive into that vast, mysterious region right below it, the mantle. So, the crust. This is our home. It's where all known life exists, but here's the crazy part. It's surprisingly thin. Think of it like the skin of an apple. That's it. And this super fragile skin isn't even one solid piece. It's actually broken up into these huge slabs called tectonic plates, and they're just constantly, slowly drifting around. And, not all crust is the same. There are actually two types. You've got the continental crust, that's the thicker stuff that makes up the land we live on, and then you have the oceanic crust, which is what's at the bottom of the oceans. It's much thinner, but also a lot denser. Okay, say goodbye to the crust. We're now plunging deeper down into the mantle. And this is where you really start to feel the massive scale of our planet's interior. Just get a look at that number, 84%. That's how much of Earth's volume is just the mantle. It is the absolute giant of Earth's layers. It's this massive region of hot, dense rock that makes the crust we live on look like, well, nothing. And here's where things get really weird. The mantle is technically solid rock, but it's so incredibly hot that it acts like a super, super thick, slow-moving liquid. The best way to picture it, think of something like hot tar, or maybe caramel, just flowing, but over millions and millions of years. And that slow flow, it's absolutely critical. It creates these huge, powerful currents called convection currents. It's kind of like a giant pot of soup simmering in super slow motion. The hot rock rises and the cooler rock sinks. And it's this churning engine deep inside the Earth that's literally dragging our tectonic plates around on the surface. It's what causes earthquakes and builds entire mountain ranges. All right, we're leaving the rock behind now. We are going deeper, descending into the very heart of the planet, the incredibly hot metallic core. And you'll see it's actually split into two very, very different parts. So after traveling through thousands of kilometers of rock, we hit something just astonishing, a massive ocean of molten metal. That's right, the outer core is completely liquid. And the temperatures here are just hard to even imagine. Take a look at this comparison. We're talking over 4,000 degrees Celsius. This swirling ocean of liquid iron and nickel is basically as hot as the surface of the sun. So you've got this massive liquid metal core, and it's constantly churning. And that movement is maybe one of the most important things for life on Earth. Why? Because it turns our entire planet into a giant electromagnet, creating Earth's magnetic field. This field is like a cosmic shield, protecting us from all sorts of harmful radiation from the sun. Honestly, without it, our atmosphere would be stripped away, and life as we know it just couldn't exist. But hold on, just when you think you've got it all figured out, we get to the very, very center and we find a paradox. Even though it's even hotter than the liquid outer core, the inner core is completely solid. So, how is that possible, right? It seems to defy all logic. Heat melts stuff. So how can the absolute hottest spot on the planet be a solid ball of metal? Well, the answer comes down to one incredible force: pressure. Just imagine the weight of the entire planet, the crust, the mantle, the outer core. All of it is pressing down on the center with this unimaginable force. It squeezes the atoms so tightly together that they can't move around like a liquid anymore. They're literally forced to be solid no matter how hot it gets. Okay, we've made it. From the surface all the way to the center. So now let's pull back up and look at the big picture here. Why does any of this matter? So a super quick recap of the journey, right? You've got the solid crust we live on. Then there's the flowing mantle that moves it all around. Deeper still is the liquid outer core, which creates that vital magnetic shield. And right at the heart of it all, the solid inner core that acts like an anchor for the whole system. Each layer has its own state and its own super important job. The key thing to remember is that these layers aren't just sitting there. They're all part of one giant, dynamic system. They're all connected. And pretty much everything we experience up here on the surface, from earthquakes and volcanoes to the very air we breathe, it's all shaped by these incredible forces happening deep, deep inside our planet. And that kind of brings us to one last big thought. Our planet is not a finished product. It's alive. The mantle is still churning, the plates are still drifting, the core is still spinning. It really makes you wonder, doesn't it? What will the Earth even look like in another billion years? What new continents, mountains, or oceans will this incredible engine inside our planet create next?